हरि करना।
Welcome to the Terminal Multiverse, the second module of Intuitive DevOps for You course. So here we will explore about the terminal verse. Most importantly, we will explore about the Linux. So the following topics we are going to look into it in this session, starting with Linux shells, getting to the shell, basic bash shell commands, more bash shell commands, understanding the shell, using Linux environment variables, understanding Linux file permissions, managing file systems, installing software, working with editors. So let's begin with know your Linux. Before you can dive into working with the Linux command line and shells, you should first understand what Linux is, where it has come from, and how it works. So basically, this slide walks you through the what a Linux is and explains where the shell and command line fit in in the overall Linux picture. Wading through the world of Linux for the first time can be a tricky experience, though this chapter takes some of the mystery out of the Linux system before you start working on commands and then bash scripts. So, other than computer hardware, a Linux system primarily consists of four important parts. The first one is Linux kernel, and the second one is the GNU utilities, and the third one is a graphical desktop environment. It's a window management software. I will explain you in detail in coming videos. And the fourth one is application software. So these are the core components of any Linux system. So each of these parts has a specific job in the Linux system. No part is very useful by itself. So for now, we will look into the computer hardware. A computer hardware is a physical device of computers that we can see and touch. For example, monitor, CPU, mouse, joystick, etc. Using these devices, we can control computer operations like input and output. So these hardware components are further divided into the following categories, which are input devices, output devices, storage devices, internal components. So let's begin with input devices first. Input devices are input devices are uh, those devices with the help of which the user interacts with the computer, or in other words, with the help of input devices the user enters the data or information into the computer. This information or data is accepted by the input devices and converted into a computer acceptable format, which is further sent to the computer system for processing. And the second important devices are output devices. These are the devices that are used to display the output of any task given to the computer in human readable form. Now we discuss some output devices in brief. So you what presently at this moment you are watching my tutorial in YouTube through a laptop or maybe a PC personal computer. So the output is coming through monitor. monitor. So monitor is the main output device. It is also called VDU, visual display unit, and it looks like a TV screen. The monitor displays the information from the computer. It is used to display text, video, images, etc. You are streaming my video presently through this output device. And second one is printer. Printer is also an output device that transfers data from computer in a printed format by using the text or images on paper. So these are both colored and black and white printer. So further, there are also different types of printers like laser printers, dot matrix printers, and inkjet printers. And the third one is plotter. Plotter, it is similar to the printer, but plotters are larger in size. A plotter is used to generate large drawings, architectural blueprints, etc. on paper, and these are high quality images and drawings and large in size. And the fourth one is speakers. Of course, you're listening my voice from the speakers, the output of the speakers. It is a very common output device and it gives sound as an output. So it is generally used to play music or anything having sound or listening to my videos. Okay, then we have storage devices. There are some devices that are used for storage purposes and are known as secondary storage devices. Some of them were discussed below. One is CD. It's a compact disc at this moment, present day. These are almost not in use, but still will understand what is CD. A CD is a circular disc that you can see on your screen, uh, circular in shape and made up of thin plated glass and plastic polycarbonate material. It has a storage capacity of 600 MB to 700 MB data. It has a standard size of 12 centimeter with a hole in the center of about 1.5 centimeter and 1.2 millimeter in thickness. There are basically three types of CDs, and that's enough delving into the CD. Let's move on to the another one, that is hard disk. The next one is hard disk. And hard disk is a non-volatile storage device that uses its read-write heads to store digital data on the magnetic surface of a rigid plate. It is generally 3.5 inches in size for desktops and 2.5 inches in size for laptops. Before I would like to also know that I have uploaded one more course, that is IPython for you, that's intuitive Python for you. In that I have clearly explained how this magnetic forces are used, how this magnetic concept is used in storing the data and old hard disks. So you can just get back to that course and then watch to get the detailed description of how this hard disk works. And before that, and to continue with our present course, then we have internal hard disk, internal cartridges, etc., and hard disk packs. These are the ones. And finally, the most important components of your computer hardware is internal components. Internal components, these are very important hard devices known as the internal components. So the most important one is CPU, central processing unit. Central processing unit is also known as the heart of the computer. It consists of three units in general known as the control unit, arithmetic logical unit, and the memory unit. So below is like the next important component of internal components is motherboard. Motherboard is the main circuit board inside a computer, and it contains most of the electronic components together. All components of the computer are directly or indirectly connected to the motherboard. So it includes RAM slots, controllers, system chipset, etc. And the next thing is RAM, random access memory. It is also known as temporary or volatile memory. It holds the program and data which are currently in process of processing. All the data is erased as soon as the computer is turned off or in case of power failure. So data stored in the memory can be changed. Basically, there are two types of RAM. One is SRM or SRAM, static RAM. Other one is DRAM, dynamic RAM. Then what is the difference? SRAM, that static RAM, consists of flip flop using a transistor or MOSFET transistor. It's the fast and has less access time. In refreshing circuits are not required, but it's costly. Whereas DRAM, that's a dynamic RAM, it consists of capacitors and the data that is stored in the form of capacitors. So capacitors charges when the data is 1 and don't charge if data is 0. So it requires a refreshing circuits as a leakage of current in the capacitor can occur. So they need to be refreshed to the data. It is slower and has a higher access time. It is cheaper in comparison with SRAM. The fundamental difference between static RAM and the dynamic RAM is the architecture and with what material it is made. If it is MOSFET transistor, it is static. If it is our capacitors, it's a dynamic. Then we will look into the Linux kernel. The core of the Linux system is its kernel. Like Windows has its kernel, it's Windows NT. Similarly, Linux has the kernel, we call it as a Linux kernel. The kernel controls all the hardware and the software on the computer system, allocating hardware when necessary and executing software when required. Let me take you through the little history class before we completely explore the Linux kernel. If you have been following the Linux world at all, no doubt you have heard the names. You might have heard the name Linus Torvalds. Linus Torvalds. Linus is the person responsible for creating the first Linux kernel software when he was a student at the University of Helsinki. He intended it to be a copy of the Unix system. At the time of a popular, at that time, the Unix system was the popular operating system, and mostly all the universities used to use this Unix system. Now, enough of history. Let us deep dive into the functionality of the kernel. The kernel is primarily responsible for four main functions. The first one is one of the primary function of the operating system kernel is memory management. Not only does the kernel manages the physical memory available on the server, but it can also create and manage virtual memory or memory that does not actually exist. And it does that, it creates that virtual memory by using space on the hard disk called the swap space. So now a virtual memory, as you interact with a program, part of it may be in physical RAM while the rest of the program is on the hard disk as virtual memory. Because virtual memory is slower than the RAM, user may notice the computer slowing down while it uses virtual memory. Now the memory locations are grouped into blocks called pages. The kernel locates each page of memory either in physical memory or the swap space. The swapping out memory pages for running applications continues for as long as the system is running. And The second function of Linux kernel is software program management. The kernel controls how the Linux system manages all the processes are running on the system. The kernel creates the first process called init. The kernel starts and then it creates a first process called init process to start all other processes on the system. When kernel starts, it loads the init process into virtual memory. As the kernel starts each additional process, it gives a unique area in virtual memory to store the data and the code that process uses. Now, some Linux implementations contain a table of processes to start automatically on boot up on Linux systems. This table is usually located in the special file called etc init tabs. Now I will go to the now